This is Dr. Mohan. I am from Institute of Aeronautical Engineering. Today we discuss about the conditional distribution, property and application in the headline of signal and stochastic processing subject. This topic is going to map with CO, PO, POS as CO4 and PO4 as well as of sustainability goal is quality education, affordable and clean energy, climate action. The CO4 that is represented as a course outcome 4 is represented as a extended the random variable concept to random process, and it is sample function for demonstrating the input domain and frequency domain characteristics. The program outcome is going to map in PO4 that is represented as a range of configuring the requirement. Sustainability goal, it's mapped with quality education, affordable and clean energy and climate action. Today we discuss about the conditional probability properties and application of conditional distributions. The conditional distribution is represented as a conditional probability, the probability of event occurring based on the given condition or prior knowledge of another event. That is represented as A and B are events. It will be expressed as P of A or B. It's indicate that probability of event A when the event B has already occurrence. We write the mathematical equation as like P of A B is equal to P of A intersection of B and divided by P of B. P of A intersection of B is represented as a probability of both event A and B occur simultaneously. P of A is represented as a probability of event and A occurrence. Okay. So then how to calculate for the conditional probability cases? We will see step by step. So identifying for the events first. The events as A and B. That's what I write as a event of A and event of B. The event of A and event of B. Event of A, it's overcome the event of B. So we need to find for the probability of events. That will be represented as a first case. Determine the probability of event of A, that is called for the P of A. Next one is another event is represented as a B. The determination of probability of event B, that is P of B, that is called for the probability of B. Then after apply for the conditional probability formula, we can calculate the required probability. The required probability is represented as P of A in B is equal to P of A intersection of B divided by P of B. Suppose the events, it will be going to overcome from B comma A. That means B slash of A, that will be represented as a probability case. So the probability of B intersection of A, B represented as a P of A intersection of B divided by P of A. Okay, we can write any possibility, that's no problem. Whether the probabilities are going to occur A or probabilities are going to occur B at the first one, it's overcome between on the A or B. It's both have the possibility. So in this condition, we write for the mathematical expression as a conditional probability is like this one. Whether we write for the P of A overcome B or P of B overcome of A, both the formula we should write like this in the probability of occurrence case. And if the conditional probability P of A in B is probability of event A occur given the event B has already is occurred. Its properties can be provided directly from the definition. Okay, so how the property is going to given for the directly definition? If the conditional probability of A and B, P of A and B is equal to P of A intersection of B divided by P of B. In this case, P of B always greater than of 0 only. Okay, in this case, P of B always greater than of 0. If not, it's not possible to occur for the conditional probability. Okay, so based on the case of P of B greater than of 0, that means P of B already occurrence, okay, in the condition of probability of event. So that condition, the P of A, it's maybe 0. There is no problem. Maybe 0. That is not per equal 0. That is maybe 0. But P of B always greater than or 0. It's not a 0. It's greater than of 0. Then only the conditional probability is going to satisfy. Based on the P of B greater than of G, we can derive the different type of property. That property is represented as conditional probability properties. For first property, the probability of certain event is 1. Okay, the condition of certain probability event is equal to 1. That is the first probability. That means if you have the set of probabilities, okay, if we have the set of probability, in the set of probability we can take it out for the some specific events. Suppose we take for the x1, x2, x3 up to x of n events are occur when it will be going to happen for the function. In this case, I make for the some set of samples. This is x1 to x3, one space. Okay, that is sample space. Another x4, x5, x6, another sample, and x7, x9, and x11. The samples are not in the uniform. It's we have a jumbling also. We take some set of spaces. Sets or sample spaces. In this condition, I write for this case of the samples, or I write for the S. Okay, this one is S, another S. This one is another S. We can specify 1, 2, 3. S1, S2, S3. But the events x1 to x of n events is going to occur when the probability condition. That condition, the probability of certain event, okay, that is called for the samples, is equal to 1. So I write P sample of B is equal to 1. So this event is overcome for the B1. B1 is occur overcome for the x1, x2, x3 of sample S. So this I write as a P of S slash B. So maybe S1, S2, S3, S3, S4, S5 up to S of n is going to have possible. So P of S, B of sample condition is equal to 1. Then S is the sample space. Okay, we take for the definition. Okay, this set I consider as a S. The set is S. The events is going to happen for the up to S of n. That is S1, S2, S3 up to S of n events are there. Each event I call for the S subsets. The subset transfer the definition of conditional probability P of S slash bar equal to P of S intersection of B divided by P. Okay, intersection of P of S intersection of B divided by B. Okay, now what is that S? S is a sample space. Okay, the intersection of the entire sample space S and any event B is simply the event we called as a P of B. Okay, I write the sample space, we taken the sample space, intersection of B is equal to P of B, that the probability is represented as a P. Why? Because of this sample is going to overcome for our entire event, that is x1, x2, x3 up to x of n is there. So here I take for the one sample base x1, x2, x3. This events is going to overcome for the our entire event. So that's what P of S intersection of B is equal to P of B I write. Okay, we need to substitute for our formula as the case P of S by B, that is a conditional property equal to P of B divided by P of B. Both these two are getting to cancel, then we get for the 1. So then what will be happen? Probability of certain event is equal to 1. That is first probability. Next, second probability. Probability of the event given itself is equal to 1. Okay. So what will happen? The P of A. Okay. Again I take for the conditional probability of P of A. The value is equal to 1. That is the meaning of probability of event given itself is 1. P of A be taken for the probability of event overcome from the event A to B. So this P of A I take for the conditional probability. If again I take for the conditional probability of P, the value is equal to 1. That is represented as a probability of event given itself is equal to 1. Now the equation P of B, condition of P of B is equal to 1. That is a condition. So I write mathematically here. Okay. As per the definition, we should use same definition of conditional probability. P of B, condition of B is equal to, as the formula P of A, condition of B is equal to P of A intersection of B divided by P of B. Now this one is represented as a B. This one represents as a B, the probability of N. So that's what I write as a P of B, condition of B is equal to, we replace A into B from the equation. We replace for the B. Now, the case, if P of B, section of P of B is equal to P of B only, we should substitute for here, P of B. Both P of B and P of B, upper and lower, it's getting to cancel. Okay, it's getting to cancel. Then what will be happen? We get for the 1. So that's why intersections of event with itself is the event. It's represented as P of B intersection of P of B is equal to 1 as a probability condition. Then we write then we say that probability of event given itself is a 1. Next probability. Next property is represented as a complement rule. The complement rule of conditional probability is represented as a P of A complement of B. Okay. Now the probability is event is occur A. That complement is represented as a P of A dash. If P of A dash with overcome of already occurrence event B, the value is equal to 1 minus of P of A condition of B, where A dash is complement of event A. Okay. Now we take for the A and A dash are mutually exclusive and their union is entirely sample space. The union always entirely sample space. Okay. So that condition we write as a union of A dash. That means we take for the inverse of A, that is A union of A dash equal to sample space. Okay, that space doesn't happen the probability condition. Okay, now I write as a P of A union of A dash is equal to S. Then A intersection of B and A dash intersection of B are also mutually exclusive. The union of two set I write as A intersection of B union of A dash intersection of B is equal to, I simplify for this equation A union of A dash, this two Write here this one. Then B is a common. But it's going to happen for the intersection. I write as A union of A dash intersection of B. This A union of A dash is equal to S. Okay. We studied here A intersection of A union of A dash equal to S. Now I apply for this condition for here. So that means what will happen? Because of A union of A dash equal to S, this intersection I take, B I will write. So now we know well, if we have for the any subset, okay, so intersection of B is equal to B. Okay, so that means there is no events are occur in the subset. So that case, what they're going to have the B in the event, that only is going to project it. So that's what I write for the B only. Next case, by additively maximum of probability P of B is equal to P of A intersection of B plus P of A dash intersection of B. Now, we need to divide for the P of B in this equation. Okay, if we divide, here what will be happen? Here P of B. These two are getting to cancel, remaining is 1. Here is P of A intersection of B divided by P of B. Here is P of B divided by P of B. We write. Now, but the definition of conditional probability density condition, 1 equal to this equation. What will be happen? This equation has a conditional probability P of A condition of B. This one we write as a P of A dash condition of B. So that's what 1 is equal to P of A condition of B plus P of A dash condition of B. Now you take it out from the left side of P of A condition of B into the left side. So now finally what will be happen? P of A dash condition of B is equal to 1 minus of P of A condition of P of B. Okay, we proved for the property of inverse. Okay, or complication. Inverse or complication. But the next probability is represented as a addition rule for conditional probability. The conditional probability also going to satisfy for the addition rule as well as a subtraction rule. Both the rule is going to satisfy. Now we see about the additional rule for conditional probability. If we event 2, you should add whether the event A and B. Okay, it's overcome from the sample space of S. If the 2 events are there, the event is represented as A and B, those will be going to overcome for the sample space of S. So then I write for the conditional probability of events P of A union of C condition of B is equal to P of A B conditional probability P of CB conditional probability minus of P of A intersection of C conditional B. Okay, we need to prove the property of additive rule in the conditional probability. Now we know the P of A union of condition of C and B is represented as a conditional probability equation. So this case, this we consider as a B. Sorry, in this case you consider as a A. What is it? A union of C. Okay. So we know P of A condition of B is equal to P of A intersection of P of B. Sorry, P of A intersection of B divided by P of B we wrote. So in the A place, I should apply for the A union of C. Okay. This equation, it's need to modify like this one. P of A union of C intersection of B divided by P of B. The next, distributive law. I am using for the distributive law theorem. So A union of C intersection of B, I should write as A intersection of B union of C intersection of B. So this statement we should apply further here. Okay, after of our conditional probability equation we should apply. So what will be happen? That will be P of A union of C condition of B, that is equal to P of A intersection of B union of C intersection of B divided by P of B. For the ordinary additional rule, the probability we have P of X union of Y is equal to P of X plus P of Y minus of P of X intersection of Y. We should take this equation to the reference of our probability condition. Now, we should apply for here. So now X is equal to this value. Okay, A intersection of B. Then Y is equal to, I take for the C intersection of B. Then we should apply for this equation. Okay, P of X union of Y is equal to P of X plus P of Y minus P of X intersection of Y. Then we apply, we get for the conditional probability is like that. P of A intersection of B plus P of C intersection of B minus of P of A intersection of B intersection of C of intersection of B divided by P of B. Now, the intersection values we need to simplify. What will be as per the case of this equation. So, P of A intersection of B intersection of C intersection of B is similar to P of A intersection C intersection B. Then I write as a equation. I should substitute for this value to this equation. P of A intersection of B plus P of C intersection of B minus of this value P of A intersection C intersection B divided by P of B. Now this value we need to distribute together. What is it? P of A intersection of B divided by B plus P of C intersection of B divided by P minus of P of A intersection C intersection of B divided by P of B. This value is represented as this two value. What will be happen? We write for the conditional probability equation to equalize. Then P of A condition B, P of C condition B, P of A intersection of C condition B. Okay, we should prove the property of additive cases. Next, Chinese rule or chain rule. We call it Chinese rule or chain rule or multiplicative rule. Okay, for the conditional probability, what will be happen? P of A intersection of B is equal to P of A conditional probability of B into P of B is equal to P of B condition of A into P of A. We write it for the any way. That's no problem. Okay, we take for the two different way. We need to prove this probability for direct consequence condition of conditional probability condition. We know the equation of probability conditional. P of A condition of B is equal to P of A intersection of B divided by P of B. In this case, we must multiply for the both side of P of B. Okay, we need to multiply for the both side of P of B. So this here also P of B, here also P of B. These two are getting to cancel. So I write the equation as like this form. P of A intersection of B is equal to P of AB into P of B. Now I need for this portion only P of A intersection of B, that is a P of A B conditional cases. The conditional case is equal to P of B intersection of A divided by P of A. Or we write it for the P of B intersection of A or P of A intersection of B. Then finally I make to write as a your probability is represented as a P of A intersection of B is equal to P of B overcome the A event and P of A. Up to this much, 5 properties getting to over. Next we go for the application of conditional distribution. We use for the lot of application in the conditional distribution in day-to-day life. Here I given for few application. One is represent risk assessment and financial cases, medical diagnosis and testing, then weather forecasting, machine learning and artificial intelligence, manufacturing and quality controller, then even everyday decision making. These are the application I am given for this topic. Apart from lot of applications are there. First we go for the risk assignment and finance cases. Generally, this conditional probability we use for the finance, medical, and the day-to-day life. Everywhere we are using. First case, default risk. That is risk assessment, default risk. How we may go for the risk in the financial institute as conditional probability given condition, risk of the borrower defaulting on loan. Okay, we need to identify who is going to possible to repay the loan. Those people only we need to give the loan in the bank sector. So that is represents the default risk. Next one is portfolio management. This portfolio management is going to make for the market events. We should predict exactly when it's going to crash, when the market is going to pour in the condition or rate in the condition. So that purpose they are using for the conditional probability. This is both the case called for the risk assessment function. Next is the medical diagnosis. We can identify for the disease when it will be going to happen in the patient based on the blood test or based on the physical measurement or anatomical measurement. That will be using for the medical diagnosis and test condition. So here they are going to given for the two things. One is represents interpreting test result as well as analyzing the symptoms. If you are going to diagnose for the 90% of people are getting accurate and 5% are it will be going to affect that. Okay, test it will be have the positive false condition case. Then we may easily detect or predict for the where the disease is going to spread in the location. Okay. So next analyze the symptom based on the doctor. Okay. They are going to measure the syntax for different type of patient. Here I take for the event of A and B. Okay. Or time or anything. The symptoms are significantly increasing or decreasing. Based on the case, we can predict that area is going to affect some kind of disease. Okay. So next, weather forecasting. Most of the meteorological department, they're using for the conditional probability to identify for the exactly which time the rain is happen or which time the sunstorm is going to happen or thunder is going to happen. Okay. Like the wind speed, all they're going to measure. First case, rain prediction. Okay, depends on the weather or temperature. We should predict for the rain is happen to or happen in the some conditional time. Next, machine learning. They use for the spam filter as well as recommendation systems. The spam filter mostly they're using for the email box. When the mail is represented as a spam, okay, so we can make for the certain keyword. Okay, some of the keyword. Suppose if the mail is not useful or some of them repeatedly going to send, then we can make us a spam to that mail. Automatically make to move the spam into the mail. Okay. Next, recommendation system. The streaming service use conditional probability to recommending condition. Then manufacturing case, we can predict for the defectness. And engineering can calculate the probability that product is defective. The given then it was the product on the specific assembly line in the event B. This helped to identify the address production usage. Everyday decision, okay, driving in the traffic. You take for the automatic uh, car or automatic detecting the particle present in the air molecule or automatic detection using the air condition when we are in house or industry. That condition they are using for the everyday detection in the probability condition. Now driving in the traffic depends on the traffic. The driver is making to move or making to drive the vehicle. Then sports betting. Some gambling companies are used for this kind of predicting cases. Conditional probability. They're finding for the odd for game based on new information. Likely key player being injured in the event which lowers the probability of the team to win the A. Up to this much, I'm going to stop this section. Next section, we will see about the expectation of probability condition. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.